Hi everyone, I hope you've had a little time to work on that handout that I sent. Please don't watch this video until you've worked through at least number 4. You don't have to have solved through number 4, but at least worked on it. I am going to spoil some surprises. Also, I know that the audio on this video will not be turning out very well. I've been having some problems with this webcam and I do not know how to fix it. So you're just going to have to deal with it. Alright, so here is the diagram from number 4. We know some of these measurements already, so at the very beginning, alpha we know is pi over 4, and beta is pi over 6. Okay, and we are looking for sine of alpha plus beta, and that's going to be the y-coordinate of A. So that's this vertical distance here. So sine of, I didn't leave myself enough room, alpha plus beta. Okay, and that's the y-coordinate of this point A up here. And I suggested that you try to find this by breaking it down into 2 pieces. So this blue distance, D, and then this green distance, C. And we can make some headway because there are several parts of this diagram that we already know. So in the previous parts of the handout, you found the length of this diagonal side that I'm pointing at here. This length happens to be sine of beta. And beta is pi over 6, and we know sine of pi over 6, that's a half. And this side here, which I'll do in yellow, it's maybe a little bit hard to see. Let me make it red instead. This side here, this also comes from the angle beta, and it is cosine of beta, and beta is pi over 6, so cosine of pi over 6 is root 3 over 2. I hope that's big enough that you can see it. Alright, so now we have these right triangles. There's this one on the bottom with the red and the green side and the bottom side, and then there's also this right triangle on top that has the blue side, this thick dark hypotenuse, and this dotted bottom side. Both of these triangles have alpha in them. I'll let you think about why that's the case. Well, the bottom triangle has alpha in it because it was defined to have alpha in it. But this top triangle, this top angle turns out to be alpha as well. Because alpha is pi over 4, that means the right-hand angle in this triangle is also pi over 4. But anyway, the top angle is alpha, which is pi over 4. And so we have these right triangles with an angle and a side. And that means that we can use some trig functions to find out the blue side and the green side. So let's start with the green side, C. So that side is opposite the angle alpha, so let's use sine of alpha. Sine of alpha is pi over 4. And that's going to be the opposite side, which is C, over the hypotenuse, which is root 3 over 2. Okay, and we can solve this for, before we solve this, sine pi over 4, we know that one, that's root 2 over 2. Okay, so multiplying both sides of this by, what are we going to have to multiply by? Root 3 over 2, I guess. On the left-hand side, we get root 3 over 2 times root 2 over 2. And on the right-hand side, the root 3 over 2 that we're multiplying by will cancel this one here. So maybe I should write it out. Multiplying by root 3 over 2. And on this left-hand side, also multiplying by root 3 over 2. And on the right-hand side, those are going to cancel. So we get just c on the right-hand side. So now we know what c is. C is root 3 times root 2 is root 6 over 2 times 2 is 4. So that's c. Now we can play the same game with this top triangle. Take a second to pause the video and see if you can, based on what you've seen with c, see if you can use the same idea to find d. So pause the video and see if you can make any progress. Okay, and we're back. So this time, looking at alpha and d, d is adjacent to alpha this time, so we'll have to use cosine. So cosine of alpha, alpha's still pi over 4, equals the adjacent side, which is d, over the hypotenuse, which is a half this time. Okay. Cosine pi over 4, that's root 2 over 2. And now we can multiply both sides of this by a half. On the right-hand side, the 1/2s just cancel, and we get just d. And on the left-hand side, we get root 2 over 4. Okay. So now we know d and we know c. The sine of alpha plus beta was just c plus d. So that's going to be, notice d and c have the same denominator, so we can put the numerators together. We get the square root of 6, that's from c, plus the square root of 2, and that's from d, all over 4. So we found the sine of alpha plus beta. Now to find the cosine of alpha plus beta, well, pause the video here to see if you can use the same idea to find the cosine of alpha plus beta. Okay, and we're back. So to find the cosine of alpha plus beta, we can do the same thing, except the cosine of alpha plus beta is the x-coordinate of our point A. So this time we're going to look at horizontal positions. Okay, we're still going to use these same right triangles, though. So to find cosine, we're going to look at this bottom side, which I think I called E on the handout. And then in this upper right triangle, its bottom side, which I believe I called F. Okay, for E is adjacent to this angle alpha, so we'll use cosine of alpha, which is pi over 4, is equal to E over the hypotenuse of this triangle, which is still root 3 over 2. And for F, F is opposite the angle alpha in this triangle, so we'll use sine of pi over 4 is equal to, the opposite side is F over, and the hypotenuse is still 1/2. It's the same hypotenuse from before. And for both of these equations, the only unknown parts are E and F, so we should be able to find E and F. So cosine pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. So for each of these equations, let's clear their denominators. So on this left-hand equation, we're going to multiply by root 3 over 2 here and here. And on the equation with sine in it, we're going to multiply both sides by 1/2 here and here. Okay, so on our cosine equation, we get on the left-hand side root 6 over 4 equals, and on the right-hand side, just e. Okay, and then in our sine equation, on the left-hand side, we get root 2 over 4. And on the right-hand side, the 1/2s cancel, and we just get f. Okay, so how do we combine e and f? Well, if we go back up to this diagram, notice that the x-coordinate we want, here, let me mark it, it's this red distance here. This x-coordinate we want is e minus f. You actually don't add them, you subtract them. You have to take away f from e. So the upshot of this is that the sine of alpha plus beta, I'm sorry, we're doing cosine this time. The cosine of alpha plus beta is e minus f. So that's going to be root 6 minus root 2 over 4. Okay, so that's how sine and cosine work out for the diagram with all of the actual measurements in them, the angles alpha pi over 4 and beta pi over 6. But next we should probably work out how everything works out if the angles are variables instead of angles. We'll do that in the next video.